Our topic for today is solving exponential and logarithmic functions. Our objective for today kind of follows that: solve exponential and logarithmic equations. This will be demonstrated on the exit ticket, the quiz, and then the final. I put up here this first part a little reminder for our log properties, because we'll be needing those later on in this notes. The first thing we're going to go over is solving exponential functions when we have a common base. And we're going to go over solving using properties of logs with one exponent. So something like this when we just have one exponent up top. And then we'll go into our log section. We're going to be talking about how to solve when we have one log, and then how to solve when we have two logs. Throughout this process, we're going to be doing something a little bit different, in that once we complete one of the problems up above for that section, we're going to come down to the you do section and we're going to complete that problem. Okay. I'm going to give you some time to work on it, and then we're going to go over that problem afterwards. So hopefully by the end, we'll have all of our you do problems done, and you'll be able to be ready for the exit ticket. All right, so let's go back up to the top. All right, it says solving exponential functions. There are many ways to solve these type of problems. We saw one way earlier today. We're going to see a different way right here. So the first thing we need to do is make our things the same base. Right? So we have this 16 and this 8. So hopefully we see that we can actually make that 16 into 2 to the 4th power, and that 8 into 2 to the 3rd power. Now, once I do those changes right here, I'm just going to replace that 16 with that 2 to the 4th, and replace that 8 with 2 to the 3rd. Find and replace. And that gives us 2 to the 4th times 3x equals 2 to the 3rd power. Now, once we have it like this, where we have two bases that are the same, then we have our exponents, so we can actually cancel out these exponents. So this 2 and this 2 can both cancel out, and they will go away. So that's why we make them have the same base, so that then we can cancel those out. That leaves us with 4 times 3x equals 3. Nice and easy that way. And then it's just a real easy problem to simplify. 4 times 3 is 12. Divide both sides by 12, and I get x equals 1/4. That's my correct answer right there. Yeah. No, you will not have to do all of this process. You could probably skip out a lot of these like little steps. Like you probably don't need this section right over here. You probably don't need to write this twice. Probably don't need to write this twice. You probably can do this math in your head as well. You can do that in your head, that's fine with me. Just know that whatever you do in your head and you get wrong is on you, and now you will not get partial credit for it. All right. That is my answer. The last thing that we're always going to do with all of these is check our answer to see if we made a mistake or if anything went wrong. So when we check our answer, we're going to plug it back into our original equation and see if it works. So instead of a 3 to the 3x, I'm going to put it 3 times 1/4. Now what I can do is I can rewrite this 1/4 right here in radical form as the 4th root of 16 to the 3rd power. Now we do some simplifying from here. The 4th root of 16 is 2. And so we get 2 cubed equals 8. And so 8 equals 8, which is a true statement. So we put a check mark next to this. And And then we highlight this to show that this is the correct answer. All right. That's the process of finding this. Make the same bases, cancel out those bases, and then do some simplifying. Are there any questions on any of this process for these problems? Do you have any questions on this? Yeah. Well, because we don't know what x equals. We still have to go through this process. Like, we couldn't just go 2 cubed and then get 1/4 as our answer, right? We still have to go through the process of checking to see if everything works out. Remember, this is my final answer right here. X equals 1/4. Are there any other questions? Are there any other questions, knowing that in a second I'm going to have you do a problem on your own, see if you understand this? Right. Let's go do that problem now, down to the very bottom where we have the you do problems. We're going to work on this first problem right here with the matching thing up top. I would like you guys to try and work on this problem. I'm going to give about 2 minutes to complete it. Let's see what you all can do. If you have any questions, like usual, you can come ask me, and then I will help you out the best of my abilities, all that good stuff. All right, you have 2 minutes to work on this starting now. So who can tell me what my first step for this problem is? What should I do first? Yeah. Great. Make that 27 into 3 to the power of 3. Should I actually write the 27 probably? What else do I need to do? Say that again. Ooh, that is not quite right. So what is 9 equal to? 3 to what power? The second power. So I'm going to rewrite that 9 right over here as 3 to the second power. Plus 5 equals 3 cubed times 12. So again, replacing that 9 right there that we had with that 3 squared, and replacing that 27 with that 3 cubed. We're multiplying by whatever we already had. So we already had that 12, so we're going to be multiplying that right there. We already had that 2, so we're going to be multiplying that right there. Return. What's my next step? Yeah. Not quite. So I canceled 3's, right? So I don't do this as the power. These are just multiplying. So actually this just becomes 2 times 3x plus 5 equals 3 times 12. Good little thing to remember. It's not 3 to the 12th power, not 2 to the 3x plus 5 power. It's 2 times 3x plus 5 equals 3 times 12. Good thinking. I had that same question when I was trying to remember how to do this. I almost did it wrong a couple times too. What's my next step? Solving and simplifying. I'm not going to do this simplifying part because I think that everybody can do that by now. What did we get as our answer? X equals what? Perfect, 13 over 3. I'm sure that everybody can do that, multiplying 3 times 12, distributing the 2, simplifying stuff. So I want to save some time and just finish up our problem as x equals 13 thirds. Get my answer. All right. Now, just like we did above, we have to check to see if this is the correct answer. So I need to go my check again. The last button. I plug that into my original equation. So what's nice about being in the computer space is that I can just copy paste things without actually having to type it in. Now, 3 times 13 over 3 is a nice number of just 13. So we get 9 to the power of 13 plus 5 equals 27 to the power of 12. I can keep simplifying there as well. 13 plus 5 gives me 18. I get 9 to the 18th equals 27 to the power of 12. Now it's hard to tell if these are actually the same thing. I could do something similar to what I did up here and change these both into 3s and see if the exponents match. Or I could just plug it into my calculator. Right, so I have my two numbers. Let's see if those two sides are equal to each other. 9 to the power of 18 is equal to that number. And 27 to the power of 12 is equal to the same giant number. But since it is the same number in each case, they are matching. That means that this right here does work. All right, so we put a check mark next to it, make it look nice, highlight our answer, maybe change the color so that we can really tell that we have a correct answer. Nice green color. And that is our answer. Are there any questions on that process of completing that problem? Either finding the same bases, canceling out those bases, or any of that simplifying? Any questions? So with the 13 thirds is I finished up this problem by distributing the two, distribute, and then I multiplied these two together and did some simplifying. But I think that everybody can do that on their own, so I'm not going to show that part. I've seen everybody be able to do this, so I'm not going to, do that extra math in the middle part right there. I'm sure everybody can do that. Any other questions? All right. Let's clear our drawings. Let's move up to the top. Back up to that first part because we have a little answer I want to answer at the bottom. When does this method work? I would like everybody to put a little note right here, write down something right here that what needs to be done for this to work. All right, maybe you start off with like this method works when ... Write down something about what you noticed about what needs to happen for this method to work, for us to be able to use this method. What has to be true about my numbers? What do I have to see right away to be able to use this? Make sure you write that down in that little box, then we'll go over. This method works when, da, da, da. Or this method works because, da, da, da. Whatever you want to write. All right. Should be enough time to hopefully write something down. Does anybody want to tell me what they put down? It's a method. Yeah. When there is a common base. What'd you say? That's exactly what I was hoping someone would say. Or you can make it into a common base. Make it to a common, I cannot type today, base. Because like we saw today, just now, these weren't originally common bases, but we can change them to be them. Now, this is a very specific case right here, where this probably won't happen very often, where we have two numbers as our exponents that both happen to work out. More in general, we'll have a problem like down here, where they can't be rewritten as exponents of each other with a common base. All right. Like I can't change 15 into some power and 285 to the base to some power, right? There's no way to make those bases match. And so what we're going to use is our log properties, specifically rewriting as a log form. Okay, so let's go over that now. First step with solving something like this is to check and see if we can change 15 and 285 into a power of something. So maybe I go try out, return 15 squared. That's 225, so that doesn't match the 285 that I was looking for. And so I can kind of tell that that's not going to work. Right? So now I'm going to use this method. They didn't match up when I tried to do some math. I can't rewrite this as 15 squared, so we'll rewrite it this other way. First thing I always like to do is rewrite my problem. I think it's a good little standard to do. And then I move some stuff around. My 285 and my 3x are going to replace each other. I'm going to put a little log out front. So my answer is going to, my log form is going to change into log base 15 of 285 equals 3x. The reason we do it this way is because now our x is on one side and no longer an exponent. So it's a nice, easy number that we can work with. We can manipulate this to be a much easier problem now. The next step is to get x by itself. So currently there's a 3 times x right now. So the opposite of multiplying by 3 is dividing by 3. Right, so I end up with rewriting my equation again, because I like to do that, as x equals log base 15 of 285 divided by 3. Now that we have this right here, this would be our answer if we were not trying to, get an approximation. We weren't trying to find some type of number. But sometimes we're asked to find it to like 2 decimal places or round to the thousandth place, that type of thing. So what we'll do is we'll use our change of base formula to be able to solve this. Remember, my change of base formula says that if I have a log, like this one right here, I can change it so that they have the same base by taking the 285 on top and dividing by the 15 on bottom. That's my change of base property. Once I have that, I do some simplifying by plugging that into the calculator. I'm going to show that now. Again, log of 285 divided by 3 times the log of 15. Gives us that 0.6957 63712. We round that to be 0.70. Now, when we check our answer right here, we end up with this check right here. Again, I plugged it into my calculator, plugged in 0.7. 15 to the 3 times 0.7 gives me this. Now I have a question for you. Hopefully this won't take too long. This is kind of, not too hard to think about. Why didn't the two answers match? We did all the correct work. I would like you to write something down right here on why this one and this one did not match. What went wrong where these two didn't match? Please put something down right there. Why didn't our final check up? Why didn't these two match? Put something down. All right. Let's see if someone in the chat can tell me, because my people in class have been giving me a lot of answers. Someone in the chat, why didn't the two answers match? You can tell me why. Perfect, I got one correct answer. Let's see if anybody else can tell me the correct answer. 1 for 1 so far. Who else thinks they know why we did not get the right answer? All right. I'm going to put their answer because we rounded up. Particularly the up part doesn't actually matter, just the fact that we rounded it all means that this problem is going to be slightly off. If I really wanted to check to see if this was the correct answer, what I have to plug in is this part right here. I can't plug in a decimal approximation of it because that's not the correct number. As we can see, it can get very off very quickly. Just by being 0.005 off, we have something that's like almost 10 points off. So if I'm plugging this in, I take my original function, 15 to the 3x, power of 3 times x, and then I'm going to replace my x with what we had before. Control copy, backspace, control paste. Since that matches what we had in the beginning, that 285, this is the correct answer. So again, I had 15 to the 3x. I replaced that x with our original thing right here, what we found to be our answer. Right there. Nice and easy. Then what I do, come back over here. Instead of saying all this check right here, I would say more like check. That sound a little bit nicer. Yeah. You will be allowed to use your calculator on the final. It'd be impossible for us to make sure you guys didn't use your calculator. So we're going to let you use your calculator. So this is going to be true whenever I'm going to use the calculator to check, is whenever I get something like this. Right? Whenever I get some answer that's not so nice. Up above, we had an answer where it was 1/4. Very easy number to plug in and check. This number down here is not an easy number to check with. Right? Log base 285 of 3 log 15. Not a nice number. Right? So whenever you see this, something with like a decimal approximation, we'll probably use our calculator to check. Are there any questions on this problem right here before I set you loose to work on the problem down below? Anybody confused on anything? Anybody want to hear more about something? Go back over it. Anything at all? All right. Let's move down then into the part that's you do practice. We're going to do the second problem down here, the solving using properties of logs with one exponent. I'm going to give you again about another 2 minutes to complete this problem. And I would like to see what you can do. So you have 2 minutes to complete this starting now. As always, let me know if you have any questions. Who can tell me my first step for this problem? All right, so seems like someone needs to be the outgoing person that they are and give me it. Perfect. Log base 2 of 25 equals y plus 1. Change it into my log form, just like that. Move the 25 over here, the exponent over to the other side. Correct answer. What's my next step? I subtract 1 from both sides. I get y equals log base 2 of 25 minus 1. Now, technically, when I'm doing this right here, I should really be putting a parenthesis around this part right here, because I cannot really subtract this 1 from this 25 right here. They're two separate things. You gotta kind of think about this log as a closed-in house. Just like with square roots and everything, they have a closed-in part that we cannot get into. Now, can anybody tell me what this is equal to, approximately? Seems like either a lot of people were not paying attention or perfect, 3.64. That is the correct rounding and everything. Perfect answer. That is my answer to this one. Now I need to check my answer. Let's actually go over this on how to plug it into the calculator just in case someone forgot. All right. I would go log 25 divided by log 2 minus 1. 3.64385,619. Now on your homework, it asks you to round to the thousandths place. So if I'm going to round to the thousandths place, I'm going to go to my third number, tenths, 100ths, 1000ths. I'm going to look at one number farther. Since that 8 is greater than 5, I would round up. It's just a little reminder on how to round with thousandths place and what a thousandths place means. For that homework that's going to be coming up. All right. Now I got to do my check again. This one, since it's not a nice number, I'm going to check using my calculator. I'm going to plug in this number right here to my original equation right here. See if it'll let me do it. Control paste. Nope. 2 to the power of y plus 1 plus 1. I replace my y with my original answer. right here. Control paste. Since that does work out in the end, I do get the correct answer. That is a correct answer, and so I would put a check mark, check, and then I would take my answer and I would highlight this whole thing. Nice and simple. So using now should be use. Are there any questions on this second problem before we move into our third section where we're talking about solving logarithms? All right then. Clear all drawings. We'll move back up to the top. So we just finished this problem over here. We're now moving into solving when I have one log. We've just finished up our exponent section. Now we're moving into our logarithm section. Right. So we can tell that we're going to use one log because of the fact that we have one log in our equation and then something on the inside of that log. To do that, I first find my base and then label it. Right? I want to remind everybody that we have an invisible base of 10 whenever we don't see a base. Whenever there is nothing down there, there's an invisible 10. Just like when we have our x value and we're trying to find an exponent, there's an invisible 1 exponent. Right? Next thing I'm going to do is I'm going to raise both sides to the base. So I raise this side to the 10 and this side to the 10, right like this. Now there's a cool fact in our math facts that this right here, if the base right here and the base right here match, they will actually cancel out and we will be just left with this 4x minus 3 part. That's what we're talking about with the b log b canceling out. If these two match up top right here and down here, that little invisible one right there, then we will actually end up with just having 4x minus 3 equals 10 squared. If we wanted to see how that worked, we could rewrite this whole thing as a second log. I could rewrite this as log of my invisible 10 to the 10 squared equals my exponent, which is already log of 4x minus 3. Now both of these logs will cancel out, so we get exactly what we had before, just flipped around. We flip them back around, we get that same answer. This is an extra step that you don't actually have to write if you don't want to. Right, this is how this actually works. But we have a math fact, a rule in logarithms, that if you have something like this, b log b, that cancels itself out and you end up with just 4x minus 3. So if you do not want to write this step right here of changing it into log form with two different logs like this, you don't have to. But if you would like to, you can do that. Then it's just solving a pretty, nice, easy problem. 10 squared is 100. Move the 3 over, divide by 4, and I get 103 over, oops, that's not what I meant to do. 103 over 4. Now, just like before, I need to check my answer. I'm going to show you my check right here. I'm going to show the whole thing, go through it. 103 divided by 4 times 4 just gives me 103, because those are going to cancel. 103 minus 3 is 100. And then to find out what the log of 100 is, I can just plug it into my calculator. Log 100 equals 2. That's what I wanted it to be, so we are good. I would put a check mark right here, highlight this, put a nice little green mark there. That's our correct answer. Now, I want to also say that there is another way to do this that I saw another student doing that I had not, seen in a very long time, and I kind of forgot existed before I made this lesson. Because again, like I said at the beginning of this lesson, there's many ways to do this. So there's a way in which you can actually skip this step right here, which I think is kind of cool. Instead of doing all this math right here, what I can actually do is just change this into exponent form. Right? So I can take this log of 4x minus 3 equals 2. And I can change it into exponent form by putting this on the outside, putting my base right here, and then my exponent goes up top. 10 squared equals 4x minus 3, which is the same thing we had before. Right? I already had these notes made for this one, so I continued showing this. But I would also like to show this method that I also saw that I thought was pretty interesting. Okay. Same answer in the end. Does the same works the same way and everything? Yeah, just wanted to show it. You can choose which method you would like to use, but remember, this is just changing into exponent form, right? And simplifying. Are there any questions on this? Any question on the new thing I showed over here or anything else? Any questions knowing that I'm about to set you loose to work on the problems down below on your own? All right, let's head down then. We'll work on that problem right there. We have the third problem right here, solving when I have one log that I would like everybody to work on. Again, I'm going to put 2 minutes on the clock and then we're going to go over it. You have 2 minutes starting now. Just like before, if you have any questions, let me know. Here to help. Over it slowly. Who could tell me my first step for this problem right here? Secondly, there's 2 different ways to do this now. You could use the first method that I showed, or we could use the second method. Let's start with this. Would we like to use the first method or the second method for this one? Let's put a poll. A little thing. I can pull some. I don't think I have that option. Someone said either. I've got 1 for 1 so far. Would anybody like to choose one? Yep. So what I'm saying is I showed a second method up above on how to do this. I showed a second way that we could do this. We could either do this full method in this, or we could change it early on and not have to raise it to the power and everything. All right, I got someone that said second method. So that's 1 for second, none for the other one. 1 for either. Someone said both if possible. We could do both. Let's do both then. So let's go over the first method first. My first method tells me that I need to find the base. The base is what? What is my base for this one? Oh, what's my base? I think you got it. kind of, that's not quite right. So base is 2, perfect. Got that right there. So what I can do right here is I can write it as 2 to the exponent of log base 2 times 4x equals the same thing over here, 2 to the power of 2. So do that whole raised into the same power like this. Now what's nice is that this 2 log 2 is going to cancel out. And so it'll just end up with new equation 4x equals 2 to the power of 2. If we do some more simplifying, 4x equals 4, which means that, nice and easy, x equals 1. Now to save us some time, so we can do this, our check is going to be leaving the teacher. This does work. If you plugged in this number right here, you get log base 2 of 4, which is just 2. Now let's go over that second method that we could have used. So instead of doing this method, we could have also done it slightly different. And we could have rewritten this in exponential form. To do that, I would rewrite this as 2 to the power of the outside number equals my inside part of my log, 4x. Then we have our answer. Let's kind of show where all that came from. Control copy. Control paste. This 2 right here got moved all the way up here. This 2 right here went right here. And then this 4x came on the other side of the equal sign. And that's where everything goes. Then it's the same process as what we did before. We get x equals 1. We could even do some of this stuff to make it kind of look more nice. Put it at the center so that we see that it's going to both of them. That's fine. All right. Are there any questions on that answer? Any questions on that process that we just went through? On either method? Anybody need me to re-go over either method? Talk about any specific steps that we took along the way? Anything? All right then. Let's move on to our last section then. We have one last problem that we're going to do. That's solving when I have 2 logs. It's actually the same process as the one above. The only difference is this first step right here, where I have to combine my 2 logs. To do that, they have to have the common base, and then I check whichever property I'm going to use. Since there's a plus sign in between, I'm going to multiply these 2 together. So I end up with addition becomes multiplication in 1 log, x minus 3 times x. And then it's exactly the same as the one above. Find my base, which is 4. Raise it to both powers if you want to, or use the other method if you'd rather use that one. That doesn't really matter though. It turns out to be the same thing either way. That cancels out and we get x minus 3 times x equals 4. Now it's just a quadratic function that we can move things around and get them in the right order. X squared minus 3x minus 4 equals 0. Then we use our x method to get this one, find out what this is equal to. Two numbers that multiply together get -4 and add to be -3 are -4 and +1. So we end up with x minus 4 times x plus 1 equals 0. And so x equals 4 or -1. I'm going to need to scroll down a little bit, so I'm going to do that now. First, I'm going to move this up so it doesn't get in my way. Scroll down. I think that's enough room. Now, we have to check our answers, see if one of them doesn't work. All right, so I plug in my 4 first. 4 minus 3 gives me 1. Then 4 is just 4, just like before. Notice I plugged it into my first one and not my second one. Right? It has to be the second one. It has to be the first equation that we got, the very first one, or we can get something that ends up being bad. 0 plus 1 equals 1, which is a true statement. Again, all you have to do is plug this into your calculator using your change of base formula, and it'll give you your answer. All right. Same thing over here. Then we have our other problem that we're going to check our answer with, the -1. Now we end up with this one not working out, this one being undefined. Specifically because we actually can't have this be negative. The reason that that can't be negative is because what we're saying is log base 4 of -4 is equal to some number. Let's say a question mark for now. This is really saying that 4 to some power equals -4. Now the problem with that is that this right here, this 4 to the power of something, is always positive. So it can never be negative. Right? So this will never work no matter what number we plug in. Because what we've seen before when we are graphing these is that it kind of came right through here and then it came up this way and never crossed that line right there. So I can never have a -4 value down here. So this will never work no matter what we plug in. And so our function is undefined at that point. Right? So it is undefined at that location. Then what we need to do, so the last step we should say is x equals 4 is our only solution, and then box it. Give it a nice green color. Are there any questions on that process of this problem right here? Any questions on this at all? Anybody confused about anything? Anybody want me to go over anything? Anything at all? If you're completely lost, it's probably something you should tell me as well. Like, man, I didn't understand any of that. You ready to go over all of it? So, talking about above, we're talking about this one right here. This up here. So this right here is one of our rules right here. The 4 log 4, that's one of our basic rules. If you don't like seeing it like that, you can also think about it as rewriting as an exponent. We can rewrite it as 2 different logs where it is. It gets messy real quick. There we go. We can rewrite this also as log base 4 of 4 to the power of 1 equals the exponent up above, which is log base 4 of x minus 3 times x. And then we can cancel out our log base 4s. That is another way to think about this. All right. Cancel, cancel. We can do it that way. There's also a log fact that says if something like this comes up, this is a opposite of each other. It'd be like having something like 3x divided by 3. That right there, those two are opposites of each other, so they cancel out. So we end up with just the x. Same thing right here. 4 to the log 4 is an opposite of itself, so those cancel out. We can also see it by doing that log process and really showing it right here that these two cancel out. All right? That's the reason that happens. Hopefully that makes sense. All right, I'm going to set you loose to work. If you are still lost, I'll continue answering questions. If you feel like you are fully good, then you can start the problem down below. I'm going to make a deal with you. If you would like to skip that problem, that is fine. You can just work on the problems on the exit ticket, start that, finish that. For those of you who are still confused about something, I would appreciate you to kind of hone in on a question. Like, what part of it are you confused about? Like, did you understand how we combined these two things into this? Did you understand how we knew the base is 4? Did you understand raising both sides to the base? Did you understand how to cancel them out? Or the simplifying part? Any specific point where you fully lost it from there?